Hello everyone. This session is going to be an explanation on how to use a predefined Excel sheet for solving short circuit and voltage drop calculations. As you can see, we have a table in front of us that contains different sections with different colors for different purposes. We also have here two tables at the bottom that relates to the transformer's characteristics. We also notice that this table is designed and prepared for a line-to-line voltage of 415 volts and a line-to-neutral voltage of 240 volts system. This means that formulas used in this table are based on these voltages. If the voltage of your country is different, like 380 volts line to line and 220 volts line to neutral, or 480 volts line to line and 277 volts line to neutral, you will just change the defined formulas and replace the 415, for example, with your line to line voltage, and also you can replace the 240 volts with the used line to neutral volts of your country. For example, if we click here voltage drop, we will see the defined formula here at this bar. So instead of the 415, you can replace it with your voltage that is used in your country. Similarly, if you find a formula with 240 volts, just replace this formula with your line to neutral voltage that is used in your country. You also notice that this table contains different colors that were made for a reason. For example, the white color cells over here are meant to be for equations and results, whereas the beige color cells that are also distributed everywhere in the table are used for the users. They are for the inputs that are from the users. Also, we can see here at the top of the table different sections for different calculations. The first section here calculates the circuit breakers related currents. And then the second section is for cables related calculations. After that, the voltage drop section that is indicated in the blue color. And finally, we have the short circuit section. Down here, we have two tables that are used for transformers calculations. The first table, or this table, calculates the resistance of the transformer, whereas the second table is just a reference for us for obtaining the impedance of the transformer for each rating or size. Actually, you either can use this table as your primary reference, or you can check the transformers catalog that will be used in your project if available for more accurate values. In the meantime, we can say that we got the key of using this table and we can start defining our inputs for calculations. And if you want to know how we can define the formulas in Excel sheet, you can go back to creating a DB schedule session and apply the explained methods. Right now, all what we need to do is to input the values of our designed project. Actually, to fill up this table, we can refer to our single line diagram to obtain most of the values needed here, like the loads, for example. We can also have the information about the cables, the type, the number of cables, the size of the cable, the millivolt per ampere per meter, and so on. But instead of that, it is always advised to gather this information of your design in one table to make it easier for yourself when calculating voltage drop and short circuit. Let's open my table in sheet 2, for example, that I frequently use, and it gathers important information like panel names, cable lengths, millivolt per ampere per meter values for each cable used, outgoing cable size, incoming cable size, and so on. What I do is I create multi-tables of this type that gathers all needed information of each panel. Now let's take this as an example and use these values for our calculation or in our calculation table to calculate the voltage drop and short circuit of these values. But first, let me copy this table and paste it over here to get back to it easily. Let me paste it over here. All right. Now we have the reference table, so we can start the calculations. First, we will start to fill the panel name cell. The first panel, which is installed directly after the transformer, is named MDB. For saving time, I'll just copy and paste over here. So the panel name is MDB. This panel has a main demand load of 1,300 kilowatts. So I will input 1,300 kilowatts. You notice that whenever I enter a number in this cell, the following cell will automatically calculate the base current or the IB, and also the next cell is going to calculate the current multiplied by a safety factor of 1.25 to give us a total current of 2,827.5 amperes. As a reminder, cells that has the beige color is used by us, the users. This means that the following cell must be filled by us. This cell represents the rating current of the circuit breaker. The nearest circuit breaker current rating for this amount of current will be 3,200 amperes. And of course, this will be of an air circuit breaker type. Now, once we enter the current or the breaker current, I circuit breaker here, the I cable current rating is automatically calculated and gave us 4,000 amperes. That is because to obtain I cable, we will divide the I circuit breaker by the D rating factor. And we said if we don't have all the information of the D rating factor, we can just assume it as 0.8. Then we will enter from where to where this cable is connected. And in this case, it is connected from the transformer to the MDB. Next, I will enter the cable type. And as shown here in the table, the cable type is this type. And the number of cables are 7. So I will enter here 7. And we have a size of one core into 800 millimeter squared. So there are 7 cables of a size of one core into 800 millimeter squared. Now I will enter the millivolt per ampere per meter value of this cable that can be obtained from a catalog. It is given here as 0.18, so I will just enter 0.18. You see, once I enter the value, the following cell divides it by the total number of cables, which is 7 cables, to give us a result of 0.0257. Next, I will enter the length of these 7 cables that connects the transformer to the main DB, which is 8 meters. You will notice that the percentage of voltage drop is calculated at this point, which equals 0.11212. Of course, it is very less amount because it is just 8 meters from the transformer. For the upstream voltage drop here, we will keep it 0 because it is the starting point, or to be specific, it is at the transformer. Right there, no voltage drop yet, so we will keep it 0 always. The following cell will give us the total voltage drop at the MDB point. Since there is no upstream voltage drop to be added, the total voltage drop will equal the same value at the MDB point. Now we will move to the other and final section, which is for the short circuit section. Since that we already have the length and millivolt per ampere per meter values defined, the resistance of these 7 cables will be calculated at this cell, which equals 0.0001. Now for the upstream resistance here, or to be specific at the transformer, we will have to calculate it. It's not like the upstream voltage drop. Here the resistance must be calculated. We will use these tables now for calculating the R transformer. But before filling up this table, I will first look at the transformer library table, which indicates the impedance of the transformer for different ratings. Assuming that our transformer is rated 1600 kVA, which means an impedance of 6% as per this table. So based on that, I will enter 6 here, and also I will enter the rating of the transformer 1600 kVA. So as a result, the resistance will be calculated at the following cell and also will be reflected on the upstream resistance over here. Note that we will only use this table at this point for the calculation of the transformer resistance only. Right now, and after obtaining the R of the transformer, we will get the total resistances, which is for the cable and the transformer on this cell. So this cell adds 2 transformer resistances, the transformer and the cable. And then, based on the obtained R total, the short circuit current will be calculated at point A, which is at the MDB and equals 36.5 kiloamperes. You can now apply the same procedures for the other panels. We will go through the same procedure again. We will write the name or the panel name in this cell and also put the load and so on to obtain the total voltage drop and also to obtain the I short circuit.